Hello guys, welcome to the Havel Lab today. My name is Babatunde, and today we're going to be talking about scientific notations with negative exponents. Okay, so what this means is we're going to have to be working with exponents. Okay, and exponents basically means power. Okay, whenever I say anything, okay, like say for example, in this question, we're giving 10 to the power minus 5. Okay, this minus 5 here is called the exponent. Okay, and we're going to be working with negative exponents in this case. Okay, so whenever we're dealing with negative exponents basically means we're going to be finding the reciprocal of whatever number we're dealing with. Okay, so say for example you have 5 to the power minus 2. Okay, we're going to have to find the reciprocal of 5, right, to remove this negative. Okay, so we're going to we want to remove this negative, and to do that, basically 5 is basically the same thing as 5 over 1. Okay, because we know anything divided by 1 equals 1, right? And reciprocal means we're going to have to take whatever is at the bottom and put at the top, and whatever is at the top we'll put at the bottom. Okay, so this will be equals to 1 over 5, and then we can now remove the minus. So this is 1 over 5 to the power 2 here. Okay, so basically that's what it means. We're just finding the reciprocals. And yeah, okay, so let's take a look at this question. Okay, this is saying this is asking us to write 8.131 times 10 to the power minus 5 in standard notation. Okay, so what's basically this means is we're gonna have to basically simplify this expression given to us. Okay, and so to do that, this is as based on what I said here, this is basically saying 8.131 times this, since the exponent here is a negative, right? And this is 10. There's nothing at the bottom. There's no decimal point. There's no there's no denominator, which is basically the bottom side of the fraction, right? This is basically just saying 8.131 times 1 over 10 to the power 5. Okay? Okay, because this is a negative exponent. Based on this example I put in here, this was a negative exponent. This one is also a negative exponent. Okay, this one didn't have a denominator. Okay, I put it over 1 because anything divided by 1 is the same number. Okay, so whenever you see a number that's like this 5 or anything that doesn't have a bottom side, it's automatically assumed that it is divided by 1. Always put divided by 1. Okay, so since I put that divided by 1, basically I now have to, because I have to remove the minus in this case. Okay, and to remove the minus I have to put in whatever is at the bottom at the top and whatever is at the top at the bottom, which is what I did here. I removed 1 from the bottom and put at the top, and 10 to the power 5 now. Okay, so now the negative is gone, so this will be 10 to the power 5 now, and I put that one at the bottom. Okay, so basically this is saying 8.131 divided by 10 to the power 5. Okay, and one way to do this is I want to count how many fives that are in the 10 I'm working with. Okay, so let's say in this case I'm working with um with 5 tens. Okay, this is saying 10 to the power 5. It basically means 10 times 10 times 10 times 10 times 10. Okay, we're gonna have to multiply 10 5 times. That's what this exponent stuff means. Okay, so now I want to count the amount of of zeros I'm going to be working with. Okay, so 10 times 10 equals what? Equals 100, right? That's equals 100. And then this 100 now, because we multiply these ones, because we want to try to find 10 to the power 5. Okay, so this 100 times the 10 equals 1000, right? That will be equals to 1000. And so 1000 times the 10 equals 10,000. Okay, and then this 10,000 and the last 10 equals 100,000. Okay, so one simple way of doing this instead of just multiplying each one of them is whenever I see 10 raised to the power anything, just replace the zeros, right, with the amount of exponents. So in this case, since it's raised to the power 5, just write 1, and then the amount of zeros behind it will be 5. Okay, so in this case, it was also 5. So that's a simpler trick instead of doing all this. Okay, so this is equals to 8.131 divided by 100k. Okay, so now we have to simplify this. Okay, we have to put this in standard notation. Okay, and so to do that, one thing I want to do is I want to, based on the amount of zeros down here, I want to kind of cancel out and kind of move this decimal point. Okay, so I don't know if you want. So what I mean by that is I want to, every time I cancel 10 at the end, because I'm basically dividing this up here by 100,000. So every time I'm dividing it, right, every time I'm removing the zeros behind, okay, I want this decimal point to go forward. Okay, because whenever I'm dividing, the decimal point is always going forward in this case. But if I was multiplying, say I was multiplying 100, the decimal point will, no, decimal point will go forward here. But if I'm dividing, decimal point will go backward. Yeah, sorry. So if I'm dividing, the decimal point always goes backward. But if I'm multiplying, the decimal point goes forward. Okay. So let's look at that. Okay, so basically what I'm gonna do here is is for every time I cancel this zero, I'm gonna move the decimal forward once. Okay, so let me put it to bigger space. 8.131 divided by 100,000. Okay, so when I cancel this first zero, the dot comes over here, right? Okay, so now it's a 0.8131. Okay, when I cancel this other zero, the dot then goes here. Okay, so now I'm housing another zero here, right? And the dot is here. Okay, if I cancel another zero, the dot goes here again. And now we have another zero here, but the dot is right here. If I cancel another zero again, the dot then goes again forward with another zero here. Another zero is housed in this big square. And then if I cancel zero again, the dot goes here. Okay, so this is 0. And then since this is a point, there has to be a 0 in front of the point. Okay, so this is the last point that we have. And the 0 has to be in front of that point. Okay, so basically this is equals to 0.01234 2348131. Okay, so let me put that in 0.00831. Correct. Okay, so thank you very much for watching the video, and I really hope it helped you out. Have a nice day ahead. Bye.